Hello, Physics B students. I miss you guys, but I will be back on Monday. And I just need to put together a couple of things that you should have learned, and then learn how to write it really well, and we'll be done. So you should have already been through this entire simulation. If you haven't, you need to stop and finish that first. Okay? Some things that we learned. If you drop an object and figure out how long it takes to get to the ground, and you shoot something else sideways, got to be sideways, that object will hit the ground at exactly the same time as the one that you simply dropped. Going sideways, only sideways, doesn't change anything about the time that it takes for an object to hit the ground. Why is that? Think about it this way. Gravity is what's making this thing hit the ground this way and actually determining the time. There is no sideways gravity, and that might be the best reason that this is true. Okay? But what we have learned, all of these paths, shoot it faster and faster and faster, they'll go further sideways, but the time will not be any different. In fact, what we did, we used this equation, d equals 1/2 at squared, and you guys figured out that the rest of it was 0. You used that to find the time for an object to drop straight down. You should also use that equation only to find the time for something to get shot sideways. And sideways motion has nothing to do with how long it takes the object to get to the ground. So, how do you use this? I'm going to turn the lights off and shut this off and show you that. So I'll be right back in a second. Let's do it this way and turn that off. Alright. Here is one of the kind of problems that we will give you, obviously not in the quiz you took today, but the next quiz we take will have a problem like this, where we know the height from which something is shot, 245 meters, and we know how fast it's shot sideways. And the question we're going to ask you is, how far sideways, well, where does it hit the ground basically? Where does it hit the ground? How far sideways is that? And you're going to say, well, I'm going to forget about the fact that it's going sideways for a little bit, because the time that it takes this object to hit the ground and the time that it takes that object to hit the ground are the same. And I know how to find the time that it takes that object to hit the ground. Because I know the distance, I know that when things drop vertically on Earth, they accelerate at 10 meters per second. And so to find the time that it takes this object to hit the ground, I would just use distance equals 1/2 at squared plus beginning speed times time plus beginning distance. Here's what I need you to be really careful with. I understand that this is a beginning speed of 20 meters per second, but that's a sideways speed. For right now, you need to completely forget about that. That has nothing to do with the time that it takes to hit the ground. In addition, I'm going to put 245 in here like we all would. I'm going to put 10 for acceleration vertically. I'm going to try to find the time. But I want you to notice this is a vertical number. It's up and down. This acceleration is vertical as well. This is a sideways speed, and you cannot put vertical numbers or quantities and horizontal numbers or quantities in the same equation and make any sense. I can't stop you from doing it, but it won't do you any good. Okay? So you guys should go through the math. I'd like to see most of you do this. 245 equals 5 times t squared. You're going to divide both sides by 5. You're going to find out that t squared equals 49, and of course t equals 7 seconds. You've all done it before, I'm not worried about it. But I need you to be a little bit more specific. This is a distance in the y direction. It's vertical, and I need you to label it that way so that I know which way you're looking. This is an acceleration in the y direction as well, and I need you to label it that way. Okay? Since really this part's 0, I probably wouldn't even have written it. If you're going to do so, you need to write S-O-Y. It's like soy, original speed in the y direction. This would be in the y direction as well. Some people ask me, how come you don't put one on t? Well, time isn't horizontal or vertical, it's just time. Anyway, be particular. This is how you indicate to me you're thinking vertically. This is how you indicate you're thinking vertically. Now the point is this thing's going to be in the air for 7 seconds. Every one of those 7 seconds, it's going to go 20 meters sideways. It's going to do it 7 times, and almost everybody knows that 7 times 20 is 140, so I can tell you right now, this is going to be 140 meters. But like in physics, always you have to show your work, and you have to show which equation legitimizes what you're doing. I would say this, it's easiest, sideways anyway, to probably use this equation if I want to figure out how far sideways the object is going. But I'm thinking sideways now, and this is the way to indicate that. Put an X. We use X for back and forth. I need to do it over here too. I know we have double subscripts going on. All this says is the sideways average speed. Since the beginning sideways speed is 20, then the speed later on is 20, the speed sideways is always 20. There's nothing going on sideways to make this number get bigger or smaller. That's why I can do this. And so when I finally get done, all I have to do is take 20 times 7, and yes, we do get 140, everybody knows that. That's how you show that. This is how you show sideways, this is how you show up and down. Now some people question, well wait, why do I need to use this equation up and down, and this equation is sideways? And the answer is you don't. If you would rather use one equation all the time, then you could simply write this equation out all over again, putting the subscripts in, sideways, 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 yes it says socks, sideways, yes it says docks. Sideways, the acceleration is not 20, that's a speed. Sideways, the acceleration is 0. And that's why this still works. Half of 0 is 0, 0 times t squared is still 0. This part turns out to be 0. The original speed in the x direction, well, it's just 20. So I'm going to take 20 times 7. I'm going to call the original distance back and forth. I can also call that 0. So once again, I still just end up multiplying 20 times 7. The point is this. Some people are going to memorize this for up and down and this for back and forth. You can do that if you want to, although you guys know I'm not big into memorization. On the other hand, if you want to use one equation that always works, you can do that. You just have to remember the sideways, things are not speeding up and down at all. Sideways acceleration is 0. So this is what we're going to show it. We're going to show vertical by doing this. We're going to show horizontal by doing this. So when you get into homework problems, so you've already done the vector problems, that's the front of the page. When you flip that over, there's another set of 6 problems on the back. You only know how to do the top 3 right now. And I'd like you to do that. If you got this far to watch the video, the next thing you should do is take the vector problems, flip them over, take a look at the 6 problems, and only do the top 3, because at this point, that's all you know how to do. On a separate sheet of paper, right? Because you're not going to turn them in. If you get that done, my suggestion would be to take a look down at the VPython assignment. Yes, there's one more. If you can get that done, that's the last VPython assignment ever. You should give that a chance. Give it a try as well. I'll see you Monday. Thanks for watching.